What is FastAPI? FastAPI is a modern, fast web framework for building APIs with Python based on standard Python type hints. The key features include automatic API documentation, validation, serialization, and asynchronous request handling. In this code snippet, we import FastAPI from the FastAPI module. We create an instance of FastAPI named app. Then we define a route / that handles GET requests. When this route is accessed, it executes the associated function readRoute, which returns a JSON response containing the greeting, "Hello world." FastAPI uses Python type hints for routing, data validation, and serialization, which simplifies the development process and ensures type safety. Comparison with other Python frameworks. FastAPI is designed to be fast and efficient. It's built on Starlet for the web parts and Pydantic for the data parts, which are both designed to be fast. Here we'll compare the performance aspect of FastAPI with other popular Python web frameworks like Flask and Django. FastAPI often shows performance comparable to Node.js and Go, thanks to Starlet and Pydantic. It's considerably faster than traditional frameworks like Flask or Django because it's an asynchronous framework. While Flask and Django are synchronous and can handle fewer concurrent requests compared to FastAPI. Core features and advantages. FastAPI is a modern, fast web framework for building APIs with Python 3.7+, based on standard Python type hints. Its main features include automatic validation, serialization, and interactive API documentation. The core features of FastAPI make it compelling for API development. Type hints and automatic data validation ensure that the data received by the API matches expected formats. Serialization is handled through Pydantic models, which convert input data into Python classes and vice versa. Interactive API documentation is generated using Swagger UI and Redoc, providing a user-friendly interface to explore and test the API. These features combined lead to development speed and fewer chances for human error. Installation and setup. To start using FastAPI, you must first set up a Python environment and install the necessary packages. FastAPI is built on top of Starlet for web handling and Pydantic for data validation, but you just need to install FastAPI itself, as it includes these dependencies. The command pip install fastapi all installs FastAPI along with all the optional dependencies, including an ASGI server, like Uvicorn, that is required to run a FastAPI application. After running the command, all necessary packages should be installed, and you can start building your first FastAPI application. Creating a simple FastAPI application. A basic FastAPI application consists of a few key parts: an import of FastAPI, creation of an app instance, defining a path operation, and running the app. Below is a simple example of a FastAPI Hello World application. The code imports the FastAPI class and creates an instance of it called app. The app.get/decorator tells FastAPI that the function underneath is in charge of handling requests to the root URL /. When a client browses to the root URL, it will receive a JSON response containing Hello World. Understanding ASGI. ASGI stands for Asynchronous Server Gateway Interface, and it's a specification for building asynchronous web applications. It is the successor to WSGI, Web Server Gateway Interface, which only supports synchronous code. ASGI is designed to be compatible with asynchronous frameworks like FastAPI, enabling the use of asynchronous features like await and async, which allows for handling long-running operations and high-performance I/O-bound tasks. The code is a simple ASGI application. It starts by importing Uvicorn, an ASGI server. The app function is an asynchronous callable that accepts scope, receive, and send arguments. Scope contains information about the incoming request, e.g., type HTTP. The send coroutine is used to send messages back to the client. This code snippet sends a plain text, Hello World response. The assert is there to ensure that the function is called in the correct context, i.e., quest. FastAPI application structure. In FastAPI, the application structure revolves around creating an instance of the FastAPI class. This instance is the main point of interaction for creating APIs, defining routes, and including middleware or dependencies. The following is a simple example of the structure of a FastAPI application. In the given code, we import the FastAPI class and create an instance named app. We define a route with @app.get/, associating it with the path. The read_route function is the path operation function for the root endpoint, returning a JSON response when a GET request is made. This code exemplifies the minimal structure needed to create a basic API endpoint with FastAPI. Routing and endpoints. In FastAPI, routing refers to the way in which a web application can route different requests to specific handler functions called endpoints. Endpoints are the actual Python functions that are called in response to incoming HTTP requests, and they're assigned to particular paths using FastAPI's routing system. The code snippet demonstrates two endpoints in a FastAPI application. The first endpoint is associated with the root path / and will respond to GET requests by returning a JSON response with a hello key. The second endpoint is associated with the path /items item ID, where item ID is a path parameter that the function readItem expects to be of type int. This endpoint will return the item ID in the response. Decorators @app.get define the type of HTTP operation and the path for the endpoints. HTTP methods get, post, put, delete. In FastAPI, HTTP methods define the type of operation you want to perform on the server. Common HTTP methods include get for fetching data, post for creating resources, put for updating resources, and delete for removing resources. Each method has different semantic meaning and use cases. In the provided code sample, we define a FastAPI application that has route handlers for different HTTP methods. The @app.get/ decorator creates a route for the get method to fetch the root documentation. The @app.post /decorator defines a route for the post method to create a new item. @app.d sets up a put route to update an item with a specific item ID. Lastly, @app.delete items_id specifies a delete route to remove an item by its item ID. Each function returns a JSON response compatible with RESTful API principles. Path parameters and data validation. In FastAPI, path parameters allow you to capture variable parts of a URL path. They are incorporated into the route's URL and typically marked with curly braces. FastAPI provides automatic data validation for path parameters by leveraging Pydantic models and type annotations. When a parameter's type is specified, FastAPI validates that the supplied value meets the criteria of the type. If the validation fails, it sends a detailed, user-friendly error response. In the provided code snippet, we've defined a simple FastAPI application. The application has a route /items/item ID, where item ID is a path parameter that accepts integers, as indicated by the type annotation int. The readItem function is the endpoint handler for the route. It takes the path parameter item ID, which is automatically validated by FastAPI to be an integer due to the type annotation. If the path parameter item ID is larger than 100, an error response is returned. Otherwise, it returns a JSON response with the item ID. Query parameters. Query parameters allow you to pass optional or required data to your endpoint via the URL. They are typically used for filtering data, pagination, or other functionalities. In FastAPI, you define query parameters by declaring them as function arguments in your root functions. In this example, we define a get endpoint at /items/. The function readItems receives a query parameter q, which is of type str and is optional, defaulting to none if not provided. When a request is made to this endpoint with a query parameter, e.g., items/q equals SUMQuery, the function searches for items matching the query. If the query parameter is not provided, it returns a message indicating no search query was provided. Request body and Pydantic models. In FastAPI, you define the data structure for a request's body using Pydantic models. Pydantic is a data validation and settings management library, which FastAPI leverages to perform automatic data validation and serialization. Using Pydantic models, you describe the expected shape of the request body, and FastAPI ensures that incoming requests are parsed and validated according to this schema. The code snippet defines a Pydantic model named item, which includes 4 fields: name, description, price, and tax. The fields name and price are mandatory, while description and tax are optional, with description defaulting to none and tax defaulting to none if not provided. This model is then used to specify the expected body of a post request to the /items endpoint. When a request is made, FastAPI will automatically parse and validate the request body against the item model. If the data is valid, the endpoint will respond with the same data. If the data doesn't match the model, a 422 unprocessable entity response is automatically returned to the client. Responses, JSON, HTML, etc. In FastAPI, you can determine the type of response that your API will return. By default, FastAPI will automatically convert your Python objects like dict, list, etc. to JSON. However, you can also manually control the response type, such as returning HTML, plain text, or custom media types. The code snippet defines two paths in a FastAPI application. The first path, /JSON, is set to return a JSON response. By specifying response class equals JSON response, we tell FastAPI explicitly to return a JSON response. The return value is a Python dictionary that FastAPI converts into a JSON response. The second path, HTML, is tagged with response class =HTML response, which indicates that the function will return an HTML response. The string returned from the function is an HTML document. FastAPI sets the appropriate content type headers for both types of responses according to the specified response class. Synchronous versus asynchronous operations. In web development, synchronous operations are executed sequentially, while asynchronous operations can be executed concurrently. FastAPI supports writing asynchronous code, which is beneficial when dealing with I/O-bound tasks. Below is an example comparing synchronous and asynchronous endpoints in FastAPI. The above code defines two endpoints in a FastAPI application. /sync endpoint is a synchronous function that puts the server thread to sleep for 5 seconds. During this time, the server could become unresponsive to other requests. The async endpoint is an asynchronous function that also waits for 5 seconds, but does so without blocking the server thread, allowing it to handle other requests while waiting. Asynchronous operations are essential for I/O-bound tasks, like HTTP requests, reading from or writing to databases, file systems, etc., as they can dramatically improve the performance and scalability of a web application. Handling errors and HTTP status codes. In FastAPI, handling errors involves returning appropriate HTTP status codes along with descriptive error messages. The HTTP exception class is used to interrupt normal flow of request processing and directly return an error response. In the code provided, we have a routes_items item ID, which expects an item ID as a path parameter. The function readItem looks for a specific item by its ID. If the item with the specified item ID is not found, a condition simulated here by checking if item ID is not 42, an HTTP exception is raised with a status code of 404, not found, along with a detail message, item not found. When an HTTP exception is raised, FastAPI automatically returns the specified status code and error message in the response. Path parameter types /conversion. In FastAPI, path parameters can be declared using Python type annotations. This feature automatically handles data conversion from the path string to the specified data type. If the conversion is not possible, FastAPI will respond with an HTTP error. Below is an example of how to define and use different path parameter types in FastAPI. In this code, 3 endpoints are defined with different path parameters. The first endpoint, /items, item ID, expects an integer, item ID. FastAPI converts the path string to an integer automatically, and if conversion fails, e.g. a non-integer string is provided, a 422 unprocessable entity error is returned. The other 2 endpoints show that any type that can be converted from a string can be used as a path parameter, such as str for user ID and model name. Validation with query, path, and body. In FastAPI, you can validate data coming from user requests using the query, path, and body functions from the FastAPI library. These functions allow you to define type annotations along with validation constraints for query parameters, path parameters, and request bodies respectively. This ensures that the incoming data adhere to the specified schemas and validation rules before they are processed by your endpoint. In the provided code snippet, we define an API endpoint that handles a GET request on the /items/item ID path. The item ID is a required path parameter validated to be an integer using the path function. The title argument provides a description for the documentation. The query parameter is optional and validated to be a string with a maximum length of 50 using the query function, where none indicates no default value and marks it as optional. The item is a required request body that must be a dictionary, enforced by the body function with indicating that the body is required. Together, these function calls enforce validation rules on incoming parameters and request data. Request headers. In the context of HTTP requests, headers contain information about the request or the client, such as authentication tokens, preferred content types, or session cookies. FastAPI allows you to easily extract and use this header information in your endpoints. In this snippet, we define an endpoint that extracts the user agent header from the incoming HTTP request. The header class from FastAPI is used as a dependency to define a parameter named userAgent, which will contain the value of the userAgent header sent by the client. If the header is not present in the request, the default value will be none. The endpoint then returns a JSON object with the userAgent info. Cookies parameters. In FastAPI, cookies parameters can be defined in your functions to retrieve cookies sent by the client in the HTTP request. They are extracted from the request by using cookie parameters in the function signature, which can be accessed like query or path parameters. In the provided code, the FastAPI endpoint /item/ is defined. The function readItems expects a cookie parameter ASGI. The cookie default factory is used to indicate that ASGI should be extracted from the cookies in the request. If the client does not send a cookie with the ASGI, it defaults to none. The function returns a JSON response that includes the value of ASGI. Form data and file uploads. In FastAPI, handling form data and file uploads is straightforward. The form and file functions from FastAPI are used to define form fields and file parameters in your endpoint. Below is an example showing how to create an endpoint that accepts a username as form data and a file upload. In the provided code snippet, an endpoint /submit/ is defined that accepts a POST request. The handle form upload function is associated with this endpoint and expects two parameters, username and file. The username parameter is defined as a string which will be obtained from form data using the form function. The file parameter is defined using the file function that specifies the expected input is a file. The function responds with a JSON object containing the username, the uploaded file's size, and the file name. Dependency injection and security. In FastAPI, dependency injection is a way to provide your route functions with reusable components. This can include access to database connections, security utilities, and shared logic. You define dependencies as callable functions that return a specific value or type. They can be included as parameters to your endpoint functions by using the depends utility. In this example, we've defined a dependency common parameters, which takes some query parameters and returns them in a dictionary. The endpoint readItems includes a parameter commons, which uses FastAPI's depends to specify that it should use the common parameters function. When we call this endpoint, FastAPI will automatically process the query parameters and inject the dict returned by the common parameters into the commons parameter. Advanced routing techniques. FastAPI allows you to define path parameters with type annotations and use pydantic models for validation. This ensures accurate data types and validation on the fly. In this code, we would use the path function from FastAPI to include additional validation and metadata for our path parameters. For instance, we could specify that an ID parameter in the path must be an integer above 0. API operation configuration and naming. In FastAPI, you can configure and give names to your API operations. This allows for a better organization and documentation of your API. We use the name and tags parameters in the path operation decorators to achieve this. This snippet demonstrates how to name an operation and associate it with a tag for better structuring of API docs. The tags argument categorizes this operation under items in auto-generated docs. The name field assigns a human-readable name to the operation, which appears in the documentation. The path function adds extra information such as title to the parameter in the docs. Pydantic models and data validation. Pydantic is a data validation and settings management library in Python, which is extensively used with FastAPI for data validation. It uses Python type annotations to validate data, allowing you to define the shape and constraints of your data in a clear and concise way. The following example illustrates the creation of a pydantic model to represent a user object with data validation. In the given code, we define a user class that inherits from base model, a Pydantic base class. The user class specifies that it has 3 fields: username, password, and age. The username and password fields use Constra to impose length restrictions on their values. A custom validator is defined for the age field using the @validator decorator to ensure that the age is not negative and is less than 100. If the age value does not satisfy these conditions, it raises a value error. The last 2 lines demonstrate how to create an instance of the user class with valid data that satisfies the model's constraints. Serialization with Pydantic models. In FastAPI, Pydantic models are used for data validation and serialization. Serialization is the process of converting complex data types, such as objects, into a format that can be easily stored or transmitted and reconstructed later. Pydantic models define the shape of data with Python-type annotations, ensuring that the data adheres to the specified schema when it's serialized and deserialized. The provided code defines a Pydantic model named item with several fields: name, required string; description, optional string; price, required float; and tax, optional float. The item instance is created with given values, and the .json method serializes the Pydantic model into a JSON string, which outputs the JSON representation of the item instance. This serialized JSON can be stored or sent via an API response. ORMs with FastAPI, SQL Alchemy, Tortoise ORM. An object relational mapping (ORM) tool facilitates the conversion between data stored in a database and Python objects. ORMs like SQL Alchemy and Tortoise ORM allow you to interact with databases using Pythonic constructs instead of writing raw SQL, hence improving development speed and code maintainability. This topic does not include a code demonstration, as it is a conceptual introduction. When using an ORM in FastAPI, it is generally selected to match the project's needs, performance profiles, and the developer's familiarity with the ORM. SQL Alchemy, for example, is widely used for its extensive toolset and flexibility, while Tortoise ORM is valued for its easy-to-use Async support. Database migrations. Database migrations are a way to manage and apply changes to a database schema over time. They help in keeping track of the database's evolution, ensuring that updates are made in a controlled and consistent manner. In a FastAPI project, you might use a library like Alembic to handle migrations. The code provides a template for an Alembic migration script. Alembic generates migration files with 2 functions, upgrade and downgrade. In upgrade, you define changes to apply to the database schema, like creating a new table or adding a column to an existing one. The downgrade function defines how to revert those changes, ensuring that the migration can be rolled back if necessary.